Hi, my name is Madelaine Wendzik. I have the privilege of pursuing a PhD in neuroscience at the University of Georgia, home of the dogs. I've always been interested in research, from middle school when I did river ecology research, to in high school when I volunteered at the anatomic pathology lab at the Medical College of Georgia, to in undergrad here when I jumped from lab to lab trying to find the most exciting research to pursue, which felt impossible. Until I stumbled upon neuroscience and I realized that was my passion. And it was also about that time I decided through neuroscience research was how I was going to ultimately give back to society. Which brings me to my current project, which I'm really excited to tell you about. Did you know that traumatic brain injury, or TBI, is the third leading cause of injury-related death in the United States? TBI can be caused by something as simple as a knock to the head by a soccer ball to something as severe as a car wreck. And this is why TBI is the leading cause of emergency room visits in the United States each year. TBIs most affect those aged 65 and older and children aged 0 to 4. However, children aged 0 to 4 will see the largest decrease in quality of life because they're still developing and they're also having to learn to live with these social, behavior, and cognitive deficits over the course of their life. So if there are 500,000 children in the US suffering a TBI each year, it begs the question, why have we not been able to develop an effective long-term therapeutic for TBI? It wasn't until recently that scientists began to explore the interplay between TBI and other organ systems. Recently, and surprisingly, scientists discovered that TBI patients will lose roughly 1/3 of their immune tissue mass in just a few months following the injury. This is startling. Immune tissue is what keeps invaders of our body at bay. It is also the tissue that stores memory of past illnesses and from vaccine that'll keep us from getting sick in the future. This was also solidified when they discovered that TBI patients weren't dying from the severe brain injury, but they were usually dying from simple infections, like the flu. So with this new knowledge, it's likely that these children are not only suffering the consequences of brain injury, but they're also having to live with a drastically diminished immune system. This is especially concerning in children because they're receiving at least 33 vaccines and boosters before they're even allowed to enter public school. These vaccines, like the measles, mumps, and rubella vaccine, are supposed to protect these children for their entire life. If these vaccines are not as effective as we think they are, we need to know and pivot to make them so. Which is where my project comes in. I'll be using a novel model of juvenile TBI and influenza to study these immune memory questions. So the two main questions that I'll be asking are, one, if an animal receives a TBI, will it be able to retain the immune memory it had to begin with? And two, if after receiving a TBI, are we able to create immune memory as much as a normal, healthy individual? If I have the honor of receiving these funds, I will explore that question. I will use these funds to specifically travel to national conferences that are accredited and speak with experts in my field so they can give me critical feedback on these novel questions. I will also use these funds to establish relationships between my lab and local hospitals where I'm hoping to acquire blood samples from TBI patients so I can compare these natural blood samples to what my artificial samples created in the lab are suggesting. So hopefully these findings are more translatable from bench to bedside. This project is not just a 9 to 5 for me. It's not just me pursuing a couple more letters after my name. It's something I'm passionate about. It's something that I want to give back to my community with. I hope I excited you by the science, and I hope I convinced you this question is one worth answering. Thank you.